Hello again. We're putting in a little more practice on analyzing voltaic cells. So let's see if we can do that again. You can start any of these cells by drawing two beakers with a solid bar of something in each. Connect the bars with a wire, put in a salt bridge, and then there's going to be some kind of liquid, probably water, in each beaker. So this is going to be true pretty much all the time. And now they tell us that one of these electrodes is platinum. And in here there is hydrogen gas dissolved in solution. This is just like when you have oxygen dissolved in the water in a fish tank. It mixes in with the water and it's just dissolved in there. It isn't broken into ions. It's still hydrogen, but mixed in with the water. And we also have hydrogen ions, so some of the hydrogen is dissolved, some is not. And that's our left side. And then they say we have a zinc electrode, and out here there are zinc ions. So out of all those things, we have to figure out what's going to react, and that means we need our redox table. So off we go to page 7 of the data book. And sorry, I still have residue from the last question on here. Okay, so remember our list. We have platinum metal, hydrogen gas, hydrogen ions, zinc metal, zinc ions, and presumably we have water. So we start in the top left and we start reading down, looking for one of these things to be our strongest oxidizing agent. Fluorine, no. Lead acid, no. Acid permanganate, nope, 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 nope. We're looking for platinum, hydrogen, zinc, or water. Platinum, hydrogen, zinc, water, platinum, hydrogen, zinc, water. Platinum, here's hydrogen, but we don't explicitly have oxygen in our cells, so we can't take this. Nope. Oxygen, water, nope. Platinum, hydrogen, zinc, water. Platinum, hydrogen. Here we are. Hydrogen ions by themselves look to be our strongest oxidizing agent. So one of our reactions is going to be hydrogen ions reducing to hydrogen gas. Good. Now that we have that, we can go to the bottom right. Clear out the stuff from last time. And again, we start looking for one of the things on our list. So platinum, hydrogen, zinc, or water. No, 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 no. Platinum, hydrogen, zinc, water. Here's hydrogen, but it's with hydroxide. We don't know we have that. And zinc metal. Zinc metal will be our strongest reducing agent. As usual, because this reaction's starting on the right, it has to go towards the left. So, back to our question. We can fill in what we just got from the table. Our strongest oxidizing agent will be hydrogen ions, picking up electrons from somewhere and turning into hydrogen gas. And our strongest reducer will be zinc metal. It will dissolve into zinc ions and release electrons. So, on our left side, hydrogen ions are going to pick up electrons. If this reaction takes in electrons, then the electrons must go this way. Hydrogen ions will float up to this electrode. Electrons will flow into this electrode. The hydrogen and the electrons will meet and will make hydrogen gas on the surface. As this reaction goes, little tiny bubbles of hydrogen will start forming on the surface of the electrode. And if there are a bunch of them, they'll start to float to the surface, and this might even start to foam or fizz if there's a lot of hydrogen being made rapidly. And then you'll start getting a little cloud of hydrogen up here. And hopefully you're ready for that and you aren't smoking, because hydrogen's flammable and explosive. You'd have to handle that carefully if you were in a lab. So that's our left side. And on our right side, the table tells us solid zinc will turn into zinc ions. So zinc metal here is going to dissolve and we're going to get more and more zinc ions in the solution. Zinc ions are colorless, so a zinc solution just looks like water. We won't see any color or anything happening out here, except because we're losing zinc metal, this electrode will start to shrink. It'll look like it's dissolving in acid. The surface will get rough, and then it'll start to look pitted, and then bit by bit it'll start to crumble and disappear because it's being eaten away as the solid metal dissolves. And this zinc reaction produces zinc ions, we put those already, and it produces electrons, so those will flow up out of the zinc. They aren't wanted. And so we have both reactions agreeing that the electrons will flow from right to left. Now, if hydrogen is our oxidizer, then what reactions are these? Are these oxidations or reductions or what? Last time I did the thing where the strongest oxidizer oxidizes the other guy and gets reduced. Another way you can think of this is the hydrogen is gaining electrons, right? They're flowing in. If you're gaining electrons, this is Leo says Ger, then this reaction is a reduction. Reduction has the letter C in it, so that happens at the cathode. This zinc reaction is throwing away electrons here, so this is a Leo. This reaction is losing electrons, so it is an oxidation. Oxidation has a letter A in it, so that happens at the anode. So this platinum over here would be our cathode, and the zinc bar would be our anode. Last thing, which way will ions move? Well, we've got the zinc reaction is throwing out zinc ions, positives, so as they accumulate, they should start moving up into the salt bridge because they're positive and they don't like each other. Positives are going to want to move right to left through the salt bridge. And over here that also makes sense because in this reaction, hydrogen ions are moving in towards the electrode and then turning into hydrogen gas and floating away. So we have a constant flow of positives from right to left. They're getting sucked into the platinum and then they're turning neutral and disappearing. So all of our positives, all of our cations are moving from right to left towards the cathode. Cations move towards the cathode. That's a rule that we're getting used to seeing. This cell doesn't seem to have any anions in it, but if there were any negative charges, they would be flowing left to right towards the anode. There's all these positive charges coming out here. This is the main source of positive charges. So anything negative is going to say, I hear there's lots of negatives over, or lots of positive charges on the right side. I'm attracted to those. I will flow left to right to get towards the anode. So generally you have positives moving one way and negatives moving in the opposite direction, just passing each other in the salt bridge. That's normal in a cell like this. So I hope you're getting some rules here that you're comfortable with. We'll have you practicing this, of course, if you aren't already. And certainly this is the kind of question you'll see on an exam where we'll just give you a cell and say, analyze this, tell us everything about it. Which way are electrons flowing? What's the anode? What's the cathode? What's growing? What's shrinking? Where are there bubbles? We can ask you any of those features about a cell and get you to fill in information about it.